Hello. In this video, I will introduce the absolute value graph with the shift, reflection, and stretch. So let's start with the parent graph. So our objective in this video is we're going to learn about the parent absolute value graph. We are going to learn how to translate absolute value graph by stretch, shrink, and reflection. And you will also learn how to combine transformation of graphs of absolute value functions. Okay. So let's just start with the beginning. Let's start with the absolute value parent graph, y equals absolute value of x. Okay, that would look like this. It literally makes that V shape. And one interesting, it starts at the origin. At this point right here is like your vertex. It starts at the origin 0, 0, and it makes this V shape. And uh, the domain is all real numbers. As you can see, you can use any x values you like. And so the range is not all real numbers. The range starts from our smallest y value is 0, and then our highest y value is to infinity. A key interesting note is just if you recall in the linear graph, they had a slope, right? It's just kind of like the same thing with absolute value. There's no number. How do I know? If you look at this graph more carefully, you realize that there is a slope. If you go from the origin and you go up one, right one, it would be at this point, right? And if you do it again, up one, right one, it goes for this point. And then if you go from the origin, if you go up one, left one, you are at this point. And then if you go up one, left one, you are at this point, right? So yeah, that's kind of like a slope. And we'll talk about that when there's a number besides one, because there is an invisible one here, right? Sometimes they'll have like a two. And I'll explain what that means. Basically, it's like the slope. So here's the parent function of the absolute value graph, y equals absolute value of x. The domain is all real numbers, and the range is from 0 to infinity. The absolute value function graph can have a horizontal shift, meaning shifting it right or left. It can have a vertical shift, meaning it shifts it up or down. And it can also have a reflection, stretch, or shrink all at once. So how would you graph those? Well, yeah, let's first take it one at a time. So let's talk about the horizontal shift or vertical shift. So graphing an absolute value graph with a horizontal shift or vertical shift or both, how do you know? So how do you know if you have a horizontal shift versus a vertical shift? In a horizontal shift, it's usually inside the absolute value, right? And then with a vertical shift, it's outside the absolute value and it's not near this absolute value, but it's like way outside. Okay, and anything inside the absolute value is a horizontal shift, and anything outside the absolute value is a vertical shift. Horizontal shifts are always the opposite. For example, if you have the graph y equals absolute value of x minus 3, did you know it has a horizontal shift up 3 units to the right? That's really strange. So just remember, I think this applies for all graphs. Horizontal shift is always the opposite sign. In this example, y equals absolute value of x minus 3 literally means you shift it 3 units to the right, not left. Okay. Now, what about a vertical shift? So we said that you have a vertical shift if it's outside the absolute value and it's nowhere near the absolute value sign. So this graph, y equals absolute value of x minus 7, has a vertical shift of 7 units down. So unlike the horizontal shift, um, a vertical shift does not change the sign. It is what it is. So if you have a minus, that means you're shifting it 7 units down. If you have a plus, it means you're shifting 7 units up. Do not change the sign. Okay. So let's look at an example. Example one says, name the shifts of the graphs. Do not graph. Okay, so we have g of x equals x minus g of x equals the absolute value of x minus 5 plus 3. Name the shifts. So I see there's something inside the absolute value. So I know that there is a horizontal shift of 5 units to the right. Okay. And then I have this plus 3. That is a vertical shift, so that is going to be a vertical shift of 3 units up. Okay. So that's it. There's no, yeah, right now it's just shifts. Now, what about stretching, shrinking, and reflection of absolute value graphs? So, okay, so the reflection, there's like other graphs, there are reflection across the x-axis and the y-axis, and it's kind of like the same rule. If you have a number in front of it, if there is a minus outside the absolute value, we know that is a reflection across the x-axis. So, for example, y equals -2 of absolute value of x. This minus means there is a reflection across the x-axis. This 2 is something else. It is like a stretch or a shrink, and that's the next thing we're going to talk about. Now, what about if you have a reflection across the y-axis? How do you know? The negative will be inside the absolute value. So an example, y equals absolute value of -2x. It's inside the absolute value, so you know it's a reflection across the y-axis. Okay. What about stretching, shrinking absolute value function? So yeah, just like we said, like right here, like the -2 right here, that -2, that minus is a reflection across the x-axis. That 2 is a stretch or shrink, and the rule states if the a value is greater than 1, then you have a vertical stretch. Vertical stretch, making the graph more narrower, right? So the larger the a value, the more narrower it gets. I know that's really strange. And if your a value is less than 1 but greater than 0, then you have a vertical shrink, making it more, I believe, skinnier, right? I mean, more wider. So that's also strange that a smaller a value will make it more wider. So go ahead and write this on your notes. The a represents vertical stretch or vertical shrink. If the a value is greater than 1, then you have a vertical stretch, making it more narrower. If the a value is less than 1, but greater than 0, you have a vertical shrink, making the graph more wider. Okay. So let's look at the graph y equals 2 absolute value of x. For example, y equals 2 absolute value of x has no shifts, but there's a 2 right here, and the a value is 2. And we said that if it's greater than 1, it's a vertical stretch by a factor of 2. Okay, okay, so now you know. Let's do another example. Okay, example 2 says list all the shifts, stretch, shrink, or reflection of the absolute value graph. We have y equals 1/2 absolute value of x minus 3 plus 4, right? Y equals 1/2 absolute value of x minus 3 plus 4. So we're going to list everything we know about this graph. So let's start with this shifts. Let's start with the shifts. So this x minus 3, that's inside the absolute value. So I know that is related to our horizontal shift. I'm just going to abbreviate it as HS of 3 units to the right. What about this +4? That's outside the absolute value and it's nowhere near the absolute value, so that's how I know it's a vertical shift. 4 units up. Okay. Then what about this 1/2? It's positive 1/2. So it's not, there's no negative, so there's no reflection, but it's like your A value, and the A value is 1/2, which is technically less than 1, but greater than 0. So that means it's a vertical shrink. Okay? So you have a vertical shrink, and I believe that's going to make it wider. Vertical shrink by a factor of 1/2. Okay? Yeah, that is example 2. Lists all the shift, stretch, shrink, or reflection of the absolute value graph. Okay. Let's move on. Hold on. Let's see if I could just scroll down. It's too slow. Okay, so now let's talk about graphing absolute value functions with shift, stretch, shrink, and reflection. So there's technically two primary ways to graph a absolute value function. And yeah, I prefer since the domain of an absolute value function is all real numbers, you can make a table. That's probably the most old school way of making a table. I honestly don't like making tables. I don't know why. I don't like it. But if it's okay, you can make a table, and if you decide to make a table, use the x values. So if you do make a table, make sure you use the x value 0 and some positive x values and some negative x values. That'll give you the best description of your graph. So just don't limit it to only using positive x values because you never know what your graph will entirely look like. So it's just good to use 0, some positive x values, and some negative x values. The other option, this is probably my favorite way because graphs can get really confusing. Pick a few points, a minimum of 3 points from the parent function, and do the add-on. So what do I mean by that? So I will explain. So your parent function is the absolute value of x. Go ahead and pick 3 points. So go ahead and if you have to make a table, that's fine. So you can use it. I'm going to use the x value 0, the absolute value is 0, 0. So 1 point is 0, 0. And then maybe I'll use a positive, I don't know, 2. And the absolute value of 2 is 2. And then what if I use -2? Because I want to use some negative x values. And then the absolute value of -2 is positive 2. So what I would do from these 3 points is just do add-ons. So if you have a horizontal shift, for example, y equals absolute value of x minus 5, this means you shifted 5 units to the right. That means horizontal shift is related to your x coordinate. So what that means is you're going to add positive 5 to your x coordinates. So you're going to start from these 3 points and then do the add-on. So you're going to add 5 to the x, so that would be 5 comma 0. And then 2 comma 2 will now be 7 comma 2 because all I did was add 5 to the x. -2 comma 2, you add 5 to the x, so 5 minus 2 is 3. Okay. And then it's the same thing with the vertical shift. So the +1 is a vertical shift, which is related to your y coordinate. So then what you do next is start with these. You always start with the previous coordinates, so you start with these. So 5 comma 0 with the vertical shift will be 5 comma 1 because vertical shift is related to the y coordinate and you add 1 to the y. 7 comma 2 will be now 7 comma 3. 3 comma 2 will be 3 comma 3. Okay. And then you do the same thing with the reflection and so if you have a number here, right, that's a reflection. I believe if you have a number here, you multiply the y coordinate by whatever that number is. Okay. So let's do some examples. Let's start with letter A. Graph completely, describe the domain and range. So, what do you want to do? We have d of x equals absolute value of x minus 4. There's only one thing that's happening. This minus 4 is, so what I would do is write down what you have. That minus 4 is a vertical shift of 4 units down. Okay. So what you do is like pick 3 points from the absolute value. So you can use 0, 0. You could use 2, and then the absolute value of 2 is 2. You can also use -2, and then the absolute value of -2 is +2. So this is y equals absolute value of x. And then if you do the y equals absolute value of x minus 4, all you got to do is minus 4 represents a vertical shift. So all you got to do is subtract 4 on the y coordinate. So 0 comma 0 will now be 0 comma -4. 2 comma 2 will be 2. And then what's 2 minus 4? -2. And then -2 comma 2 will be now -2. And then what's 2 minus 4? -2. Okay. And then if you plot those points, you should get your graph. So let's see if we get. Okay, so go ahead and plot that point. 0 comma -4. 1, 2, 3, 4 would be right here. 2 comma -2 would be right here. -2 comma -2 right there. As you can see, it makes that V shape. So if you connect these dots, and obviously you can use more than 3 points from the parent graph. You can use more than 3. I'm just using 3, for example. Okay. Now, if that confuses you, what you could do is just make a simple table. And what I recommend is using 0 as one of your x coordinates. So 0 comma -4, that would be -4. And then I recommend using some positive x values. So you can use +1, +2, and then use some negative x values like use -1 and -2. Okay. And somehow you're going to get this kind of V-shaped graph. Okay. Okay, let's look at B. Mx equals absolute value of x plus 1. So what's really happening? I believe there's only one thing that's happening. The x plus 1 represents a horizontal shift of 1 unit to the left. Okay, so recall a horizontal shift is always the opposite sign, even though this is a plus. it really means shifting it 1 unit to the left. So what you could do is make a table, or you can start with the parent function, right? You can start with y equals absolute value of x and pick some 3 points from that. So maybe if I use 0, 0, and then maybe I'll use 4. What's the absolute value of 4? 4. And then what about negative 4? What's the absolute value of negative 4? Positive 4. Okay. And then what you do is just do the add-ons. So we said that the x plus 1 is a horizontal shift of 1 unit to the left. So what you do is you're going to subtract 1 from the x coordinate. Okay, so 1 comma 1 will now be negative 1 comma 0. All I did was I subtracted 1 or negative 1 from the x coordinate of your 3 points. That's it. So do you know what 4 comma 4 is going to be? Yes, it would be 3 comma 4, right? Just subtract x from the y coordinate. I mean, subtract 1 from the x coordinate. And do you know what negative 4 comma 4 will be? Yes, it would be negative 5 comma 4. As you can see, I subtracted negative 1 from negative 4. That's how I got negative 5. The y stays the same. And we are good. We can plot these 3 points and you should get your graph. Okay, so negative 1 comma 0 will be right here. 3 comma 4 would be 1, 2, 3, and then go up 4, 1, 2, 3, 4. And then negative 5 comma 4 would be 2, 3, 4, 5. 1, 2, 3, 4. Okay. Connect the dots, and you've got your graph. Okay. Now, if all fails, you can always make a table. Just make sure you use x value 0 and some positive x values and some negative x values. Okay, that's it. Okay, C. You have q of x equals negative 3 half absolute value of x. So what's happening here? There's two things, right? There's a minus, so that is a reflection. Oh, I forgot to add. It said to on the previous problem, figure out the domain and range. So forgot to do that. So if you look at this graph here, what's the domain? It's still all real numbers. What is the range? The range is not all real numbers, so my smallest y value is still at 0 and it's included, so bracket 0 to infinity. Okay, what about the one on the top? What would be the domain? The domain is still all real numbers. Would be the range. The range is, I believe it's going to be 1, 2, 3, 1, 2, 3, negative 4, and we include it to infinity, right? Okay, now let's look at C. We have Q of x equals -3/2 absolute value of x. So what's really happening? Is there any shifts? No. Um, is there a vertical shift? No. We have this -3/2 right next to the absolute value. So what about the minus? What does that represent? That is a reflection. Now, is that across the x-axis or the y-axis? I believe it will be, if it's in front of the f of x, it's a reflection across the x-axis. Okay, but what about the 3/2? That's a scalar. That's an a value, which is, what is 3/2? 1.5, right? So 1.5 is greater than 1, so we know that is going to be, it's your, yeah, that's greater than 1, so you have a vertical stretch. So what that means is it's going to make it more narrower. Okay, so what you could do is start with the parent function and then just, so parent function would be y equals absolute value of x. So pick 3 points from this graph. So you can use any x values you like. So you can use 0, 0. I could do 3, and then absolute value of 3 is positive 3. And then I can also use -3, and then absolute value of -3 is positive 3, right? Okay, then what you could do is if you have a number right near the absolute value, you basically multiply the y coordinate by that value. So 0, 0 will now be 0, 0. 3, comma 3 will be 3, and then you multiply the y coordinate by -3/2. So what's 3 times -3/2? That is -9/2. Okay. And what about this one, -3? We're going to multiply 3 by -3/2. 3 times -3 is -9/2. Okay? And then you have your points. The other way we could do this is I'm not going to make a table, but remember before in the beginning of the lesson, we said that the absolute value has a slope, and the slope is whatever the number right next to the absolute value, right? So, for example, y equals absolute value of x has an invisible slope of 1. It's the same thing here. We have a slope of -3/2. So I'll show you. I'll show you. So basically, it would look something like this. We start from the origin 0, 0, and then our slope is -3/2. So from the origin, what you could do is go down 3, 1, 2, 3, and then 2 units to the right. 1, 2. So dot there. Then what you would do next is go from the origin 0, 0, go down 3, 1, 2, 3, and then 2 units to the left, because it has to make that V shape, right? And then just continue the process, and you should get a graph like this. Now, you could also just plot these points, 0, 0 is right here. What's 3 comma -9/2? -9/2 is like negative 4.5. It's totally appropriate. Like you can do that, and then negative 3 comma negative 9 absolutely. Negative 3 comma negative 4.5. So you could do that. You could plot those points 3 comma negative 9, negative 4.5, 2, 3, 4, negative 4, so negative 4. Yeah, it would be right this point. And then negative 3 comma negative 9.5 would be right about this point. Okay. So yeah, that's how you basically would do it. That. So yeah, there's a lot of ways you can graph absolute value. So what would be the domain? The domain is still all real numbers. The range is smallest y value is not 0. 0 would be the highest y value. So our smallest y value is actually negative infinity, and then it stops at the y value 0. Good. Makes sense? Good. Okay, what about this graph? Y equals k of x equals negative 3 of absolute value of x minus 6. So there's three things that's going on, right? The x minus 6 means it's a horizontal shift of 6 units to the right. The minus 3 is, well, the minus is a reflection. So it's a reflection across the x-axis. And what else? What about the 3? The 3, just the positive 3, not including the minus, that is an a value and it's greater than 1. So we said that if it's greater than 1, then you have a vertical stretch, making it more narrow. So it's going to be concave down and more narrower. That makes sense. Okay, so now how would you graph this? What you could do is start with the parent function, y equals absolute value of x. And what you could do is pick 3 points from this absolute value graph. So maybe I would always use 2, and then maybe I can use 2. Absolute value of 2 is 2. And then if I use negative 2, the absolute value of negative 2 is positive 2. Then what you would do is do your add-ons. So which one do you want to do? You want to do the minus 3? That's fine. So y equals negative 3 absolute value of x. See how I'm doing it one at a time? So let's do the minus 3, which is we said that if the number is in front of the absolute value, you multiply the y coordinate by that number. Okay, so 0 comma 0 will now be 0, still 0, 0. 2 comma 2 will be now 2, and then multiply the y coordinate by negative 3. So 2 times negative 3 is negative 6. Negative 2 comma 2 will now be negative 2, and then you just multiply the y coordinate by negative 3. So 2 times negative 3 is negative 6. Okay. And then the last one is the horizontal shift. So you could do y equals negative 3, absolute value of x minus 6. Okay, so you always start with the previous point. So 0, 0 will now be, x minus 6 is a horizontal shift of 6 units to the right. So you're going to add 6 to the x coordinate. So 0, 0 will now be 6 comma 0. Okay, as you can see, I left the y from these points here. You always start with the previous points. I left the y coordinate alone and just added 6 to the x. So that's how I got 6 comma 0. 2 comma negative 6, you add 6 to the x, so 6 plus 2 is 8, minus 6. Negative 2, negative 6, you add 6 to the x coordinate, so negative 2 plus 6 is 4. Okay. And then these are your final points, and then you just plot them and you are good to go. Eight comma -6. 4 comma -6. 1, 2, 3, 4. There we go. And then if you connect these three dots, it has a V shape. It's going to look like that. So you can see it is a little bit more narrower and it is a reflecting, right? And what would be the domain and range? So the domain is still all real numbers. The range is what? So my smallest y value is -infinity, and my largest y value is, I believe it's 0. If all fails, you can make a table, right? You use the x value 0 and then some positive x values and some negative x values, right? That definitely will work. Okay, now you have a good understanding how to graph when there's like add-ons, right? If there's reflection shifts. Okay, what about this one? E. We have y equals absolute value of x plus 4 minus 2. So list whatever you have, or list whatever happening. So this x plus 4 is a horizontal shift of 4 units to the left. And then this minus 2 is a vertical shift of units down. Okay. So what you're going to do is start with y equals absolute value of x, the parent graph, and pick 3 points. So I can use the x value 0, 0, and then maybe I can use the x value 2. The absolute value of 2 is positive 2, and then maybe I can use -2. The absolute value of -2 is positive 2. Okay. And then just do it, add the add-ons one at a time. And then what I'm going to do is graph y equals absolute value of x plus 4. We said that the x plus 4 represents a horizontal shift of 4 units to the left. So all you got to do is just, all you got to do is do -4 on the x coordinates of the previous point. So 0, 0 will now be -4 comma 0. 2 comma 2 would be -2 comma 2. -2 comma 2 will be -6 comma 2. Okay. And then do the -2. So now yeah, y equals absolute value of x plus 4 -2. So the -2 is a vertical shift, and that's related to your y coordinate, and you don't change that at all. So -4 comma 0 will now be -4 comma -2. -2 comma 2 will be -2, and then 2 minus 2 is 0. -6 comma 2 will be -6, and then 2 minus 2 is 0. Okay, and then just plot these 3 points, and you're good to go. -4, -2, 1, 2, 3, 4 would be right here. -2, comma 0 would be right here. -6, comma 0, -4, -4, -5, -6 would be right here. And obviously you can do more than 3 points, right? I'm just doing 3 points. So here is my graph. Okay, good. Let's move on. What about this one? F. Oh, wait, I forgot to do the domain and range. So the domain is all real numbers. And then the range, what is my smallest y value? I believe my smallest y value is -2. And it's always included, so it's bracket -2. And then my highest y value is infinity. Okay. What about f? B of x equals absolute value of -4x plus 2 of plus 3. So I don't I don't like how they have a negative inside the absolute value. So what you could do is you can factor inside the absolute value. You could factor out. You could do factoring. You could factor out a -2. So this would be positive 2x minus 1, right? -1. Yeah. And then you could put this minus to it in front of the absolute value. And then go from here. Right. What can you do? So this one says, yeah, yeah, let's do the add-on. So start with, yeah, let's start with the add-on. So start with y equals absolute value of x, pick 3 points. And maybe I'll use 0, 0, and then I'll use, let's see, maybe I'll just keep it simple, 1, comma 1, and then maybe I'll use -1, comma 1, because there's a lot of going on, right? And then let's just do it one at a time. So y equals, let's do the -2. -2 absolute value of x. So we say that if there's a number right next to the absolute value, you multiply the y coordinate by that number. So 0, comma 0 will still be 0, 0. 1, comma 1 will be 1, comma -2. -1, comma 1 will be -1, and then multiply the y coordinate by -2. Okay. Now that 2x minus 1 is a horizontal shift. So go ahead and that 2x minus 1 is a horizontal shift of, I believe, 1/2 units to the right? And how do I know that? Basically, what I did was you can set whatever is inside the parentheses, I mean, the absolute value, set that to 0, and then solve for x, right? You could do that. So we have a horizontal shift of 1/2 units to the right. So what that means is you add 1/2 to the x coordinate. So 0, 0 will be 1/2, comma 0. 1, comma -1 will be 1.5. -1, -2, we would do is negative 0.5. Okay. And then do the add-ons. The +3 is a vertical shift. So you add 3 to the y-coordinate. So you always start with the previous point. 1/2 comma 0 will be 1/2 comma 3. 1 point comma negative 2 will be 1.5. And then negative 2 plus 3 is 1. Negative 0.5 comma negative 2 will be negative 0.5. And then negative 2 plus 3 is 1. Okay, then you would just plot these 3 points and you got your graph. Do you see how I do that? Like I just start with the parent function, pick 3 points, do the add-ons, right? Now, if this confuses you one bit, go ahead and make a table. Start with x value 0, some positive x values because your domain is all real numbers, 1, 2, 3, and then some negative x values. Okay? It's a bit more time consuming than this way, but it'll do the job. Okay, so if, I'm not going to graph this because you get the idea. You just plot these 3 points and you got your graph. Okay, let's do more. Example 4 says write an equation that represents the given transformation of the graph g of x equals absolute value of x. So what they're saying is you start with this, your parent graph, absolute value of x, and we got to do a vertical translation. We got to find a new equation of a vertical translation of 7 units out. So a vertical shift, that's what they're saying. So maybe we'll call it h of x, and then there's no horizontal shift, so it's still going to be absolute value of x. And then a vertical translation of 7 units down is just going to be minus 7. Okay. B, horizontal shift 10 units to the left, so that is related to the absolute value. So we'll call it, I don't know, R of x, you can call it whatever you like. Horizontal shift of 10 units to the left, so that means it's absolute value of x plus 10. Yeah, because remember horizontal shift is always the opposite. We want 10 units to the left, so x plus 10 means negative 10 or 10 units to the left. Vertical shrink of a factor 1/4. So a vertical shrink, when did we say vertical shrink? Is when the a value is less than 1 and greater than 0. So I think it's just going to be, let's call it y equals, I think it's just going to be 1/4 absolute value of x. That's it. Okay, because we know that 1/4 is technically less than 1, but greater than 0. So that's how I know it's a vertical shrink. And if the a value is greater than 1, you will have a vertical stretch. Okay, does that make sense? Good. Okay, this one, example 5 says describe the transformation from the graph. So they give us a new equation. We got to just find we got to just describe in words what's happening. So if you compare this with the parent function, right, absolute value of x, what's happening? Well, I believe there's 3 things. X minus 3 means you have a horizontal shift of positive 3 units to the right. This plus 5 means you have a vertical shift of 5 units up. This minus 1 is a reflection across the x-axis. Okay, and let's do this one, B. Well, there's three things that's happening. The x plus 4 means there is a horizontal shift of 4 units to the left. This minus 1 is a vertical shift of 1 units down. What about this 1/2? It's positive 1/2, so there's no reflection. Well, we said that I just, if A was less than 1 but greater than 0, this is technically 1/2 is technically less than 1 but greater than 0. They say that it is a vertical shrink by a factor of 1/2. So what that means is you're making it, the graph will be the V shape will be a bit more wider. Okay. C. C states you have j of x equals negative at the absolute value negative x plus 1 minus 5. So I don't like that minus inside the absolute value. But what you could do is like factor out a minus. So this is going to be positive x, and then this is going to be minus 1, right? And then it's still under the absolute value. Then what you could do is you could factor out this minus 1 or this minus or this invisible negative 1. That's perfectly fine. Now we can see this graph much more clearly. So there's three things that's going on. The x minus 1 represents a horizontal shift of 1 unit to the right. This minus 5 is a vertical shift of 5 units down. This minus 1, it doesn't make it wider or skinnier because it's 1, but this minus means it's a reflection across the, I always forget, it is a reflection across the x-axis. Okay, that's it. That is the absolute value. Now you can do the same methods for other graphs because you're going to learn about other graphs with stretch, shrink, reflection, and all that stuff. You can do that same method for other graphs. Okay, so I'm going to stop here.